Hi, I'm Lane Christiansen. In this video, we're going to talk about the quotient of two functions. I think quotient is a very nice word. Problems look something like this. I'd like to work through the first one with you, and then when we get to the second one, I'd like you to pause the video and see if you can work it out yourself. So I'm going to copy this onto the blackboard so that we have a little bit more room to work this out. Okay, this is what we are working with. We've got two functions, and our first problem is going to be to find the value of the quotient function. So just like in this fraction, what we need to do is we need to start by dividing these two functions, right? So what we need to write is the function g of x, or the quotient g of x divided by h of x. So to do this, all we have to do is we have to make a fraction and put 4 plus x times negative 4 plus x. And then on the bottom, we are going to write the function h of x, which is negative 9 minus x. So this is the quotient. This is equal to g divided by h of x. So this first part is asking us to plug in negative 2 to this quotient function here. So really all we have to do is we have to plug in negative 2's everywhere that we see x's in this fraction that we've made. So I'm going to start by writing this, but I'm going to open up some parentheses where the x's are. Okay, I hope you see how I opened up some little parentheses everywhere that I saw an x. So my next step is going to be to plug the negative 2's into those parentheses right here. Okay, now we need to simplify this as much as possible, but this is our answer. This is the value of the function at negative 2. So in this first set of parentheses, I'm looking right here, we have 4 plus negative 2. And what is that? That is the same as 4 minus 2, which is just 2. So inside that first pair of parentheses, we have the value 2. So I'm going to keep it in some parentheses. What do we have inside that next pair of parentheses on the top? This is negative 4 plus negative 2. That's negative 6, right? Now on the bottom, I'm just going to take one step at a time here. I'm going to write this as negative 9 plus 2, right? Like these two negative signs and that parenthesis kind of make a plus sign. Okay, so on the bottom we have negative 9 plus 2. All right. Now in our next step, let's multiply these numbers on the top, right? Because these two parentheses are written right next to each other, that means multiplication. So 2 times negative 6 is negative 12. What do we have on the bottom? Negative 9 plus 2 is negative 7, right? So this is equal to positive 12 over 7, or these two negative signs can cancel out. So that's our answer for part A, 12 over 7. For part B, they want us to find the values that are not in the domain of this quotient function right here. Okay, the values that are not in the domain of that function are going to be the values that would give you a 0 in the denominator. Remember that you can't divide by 0. So if we plugged in some x value and we got some things on the top, like, from these two parentheses up here, and then on the bottom we ended up with a 0, well then the x value that led to that could not be in the domain because we can't divide by 0. So we have to find I'm not going to rewrite the top part of that function, we'll just call it squiggle, but where is the bottom part, negative 9 minus x, where is that going to be 0? So what we need to do is we need to write negative 9 minus x equals 0, and then solve this for x. And that's going to tell us the values that aren't in the domain. To solve this for x, we should start, I think, by adding 9 to both sides, okay? We'll do plus 9 and plus 9. And we will get negative x equals positive 9. Well, if negative x is positive 9, then I think it's clear that x is negative 9. All right. So the value of the function at -2 for part A is 12 over 7. And the only value that's not in the domain is the number -9. So let's go back over to Alex and we'll put this answer in. Okay, so we've got 12 over 7 for the first part, and -9 is not in the domain. This problem is similar. I'd like you to pause the video if you like and try to work this out on your own. This is how I would approach it. Our first step is going to be to write the quotient function. So we need to put the function g on the top of a fraction and the function f on the bottom. Okay, so g over f of x. So all we do is we take g and we copy it onto the top, and then we take f and we copy it onto the bottom. X plus 3 times x minus 3. All right. To find g over f of 4, we need to plug in a 4 for x. So all we need to do is write the number 4 wherever we see a x on the right-hand side here. So we're going to have 4 plus 1 on the top. On the bottom, we'll have 4 plus 3 times 4 minus 3. And let's work out what that is real quick. 4 plus 1 is 5, right? On the bottom, we're going to have 7. 7 times 4 minus 3 is 1. 7 times 1. So our first answer should just be 5 divided by 7. Let's go ahead and put that in. All right. For the second part of the problem, we have to write the values that are not in the domain. Give me just a second and I'm going to clear off the screen. The values that are not in the domain are going to be the values that would make the bottom of this fraction 0, or the values that would make f of x 0. So where is this x plus 3 times x minus 3, where is that equal to 0? Okay, and we're setting this one equal to 0 because the f is on the bottom, and this is the function f. There are two ways that this could equal 0, because on the left-hand side here, we're multiplying two things. We're multiplying x plus 3 and x minus 3. If either one of them was 0, our answer would be 0. So like if we had 0 times a different number over here, well, then it would be 0. And if we had a different number times 0 for the second parentheses, then our answer would also be 0. So if either x plus 3 or x minus 3 is 0, our answer is 0. So this is how we would express that. X plus 3 equals 0, or x minus 3 equals 0, right? We can solve both of these for x very easily. This one's going to be x equals, x equals -3, and this one is going to be x equals +3. If either of those were the x values, then our denominator here would be 0. So those are the values that are not in the domain. Let's go ahead and plug those in. -3 and, or comma, +3. Okay, let's work on one more problem. And again, if you'd like, please feel free to pause the video and try this on your own. And then when you're ready, come back and see if what I've done matches what you've done. All right, in this problem, we're going to put the function f on top. So we're going to write 5 minus 4x squared over 2 minus 3x, right? And I'm putting the f on top because that's where the f is right here. Now we want to find the value of this function at -1, so I'm going to start by writing the whole function, but I'm just going to open up some empty pairs of parentheses wherever I see an x. And then I'm going to put the value -1 in both of those parentheses. Okay, and let's evaluate this. Remember PEMDAS, we should start by just working on the exponent in our first step. So 5 minus 4 times, what is -1 squared? That is -1 times -1, which is +1. So this is going to be 4 times 1 right here. Or, well, that's just That's just minus 4, right? We don't need to write the times 1, so that takes care of our exponent. And I'll write what we've got on the bottom. Minus 3 times negative 1. Okay, next we've got parentheses done. Well, nothing to do in these parentheses. We took care of exponents. Multiplication. I see multiplication down here. So what is 3 times negative 1? That's negative 3, right? So this is going to be 2 minus negative 3, or 2 plus 3 in the denominator. Okay, next let's add 2 plus 3 on the bottom is 5, and 5 minus 4 on the top is 1. All right, so 1/5 should be the value of the function at negative 1. 1/5. All right, now what values are not in the domain of this function? Well, we look at the function and we say, okay, we can't divide by 0, so where is the denominator going to be equal to 0? Where is 2 minus 3x equal to 0? Let's solve this by subtracting 2 from both sides so that we would have negative 3x equals negative 2. And then we'll divide both sides by negative 3. So x is going to be negative 2 over negative 3, which is equal to positive 2/3. Right, so that's our answer for the second part, 2/3. And we'll check if that's right. Okay. I hope that was helpful for you. If you have any questions, feel free to ask them in the comments, and the tutors at the Hava Lab would be more than happy to answer them. Thank you for watching this video.